Hi, welcome to all of you on this very exciting class on time and work. Time and work is one of the most frequently asked concepts in any competitive exam. Okay, you'll invariably get 1, 2 or more questions on time and work for sure. So do attend this class carefully, work out the problems that we'll do and solve some more problems so that you can get confidence in this chapter. The best part about time and work is that there is no formula. Yes, there's absolutely no formula involved. It's all just some simple concepts which are used to solve questions on time and work. Okay, what we are going to do here is we are going to cover the following concepts. Okay, we are going to look at time taken by an individual or a group of persons to do a piece of work. Okay, we'll start with that. Then we will look at relation between work, men, hours per day, number of days, how they are all interconnected, how we find out work days or work hours and those concepts. We then will learn to compare efficiencies of a person or a group of persons. Okay, then we'll find out the time taken by a group of individuals to complete a piece of work when we know their individual efficiency and when we do not know their individual efficiency. We'll also learn how to divide wages. Wages is payment for a work done. If there is a group of people working, then how do you divide money between all those people? Okay, basis the amount of work that they have done. And then in the end, we are going to look at a special case of time and work, which is pipes and cisterns. Okay, because pipes and cisterns involve some unique concepts, which I'll tell you. So we'll look at that. So what we'll do, we'll break this whole class on time and work into small modules so that it is easy for you to grasp the concept, practice some more questions on what we discuss, and then move on to the next part. Great. Okay, so let's get starting. Okay, to get started, let's understand that work done, okay, what you see here, okay, this work done cannot be measured per se. See, this is maths. Okay, we are not talking of physics. Physics has a formula for work. It has formula for a lot of these things. But for us, work will be one unit of work. As simple as that. Okay, it'll be one unit of work or one piece of work. So we'll keep the definition very simple. One unit of work, one piece of work, or something like that. So we are not really going to get into what is the work. So let's say I make a very simple statement like this. If a person does a piece of work, so see here work is defined as a piece of work. So if a person does a piece of work in n days, then in one day he will do 1 by n of the work. Okay, so this is the first and primary concept which you have to understand. So basically, if I'm saying that a person can complete a work in 20 days, then every day he is going to do 1 by 20th of the work. Okay, total he takes 20 days to finish the work. So he will do 1 by 20 work each day. He'll work for 20 days. So that means at the end of 20 days, he would complete one work. Okay, so what is the inherent assumption here? The inherent assumption, and that's some assumption that we'll make in time and work. So the assumption here that he does same amount of work every day, or he is working uniformly. Okay, this is by default an assumption that we'll have in all the questions unless stated otherwise, that a person will do the same amount of work every day. He'll put in same effort every day. Okay. Now I can look at this in two ways. One, there's a fraction concept. So if he completes the work in 20 days, in one day, he is going to do 1/20th of the work, and 1/20th, 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 you would add it for 20 days is same as 120 multiplied by 20. So that means one unit of work or one piece of work has got completed. Fine. The second way of doing this is instead of 1 by 20, I can say 1 by 20 as a fraction is what? 1 by 20, if I want to convert this into percentage, 1 by 20 will convert to 5%. So I can also say that he does 5% work every day. and he has to reach 100%, right? So 5%, if I multiply by 20, it will give me 100%. So he has to work for 20 days to complete the work. Okay, so we also use percentage sometimes. Okay, though the problem with percentage is that you may not always get a very good percentage. For example, if this person can complete his work in 16 days, then in one day he'll do 1 by 16. Now 1 by 16, you may not be very comfortable converting this to a percentage. Okay, so a reciprocal is better, but both the approaches are fine. So we say that in one day he can do 120 of the work, or we say that he does 5% of the work. If you are taking 1 by 20 like this, total work will be counted as 1 unit. So this is 1. And if you are taking in percentage, then the total work has to be counted as 100%. So whichever way you do, it's absolutely fine. There in units, you take the work as 1 unit. In percentage, you take the work as 100%. Okay, and our assumption is that the person is working uniformly. That means every day he is going to do same amount of work. It will not vary. Unless question says otherwise, then we have no choice. We'll have to obviously take that. So I hope this is a very simple concept. Okay, let's do one quick question on this so that you get a grasp of this, and then we'll move on. So we have two people, Aman. Aman can do a piece of work in 10 days, while Baman can do the same work in 12 days. And then the work will be completed in how many days if they are working together. Okay, if they work together. Okay, both of them are working. Now tell me one thing. A can finish it in 10 days. B can finish it in 12 days. So together, just before we solve, together, is it going to be less than 12, 10 to 12, or more than 12? Let's first figure out this. What will be the answer? Less than 10 days, 10 to 12 days, or more than 12 days? I'm sure this is not very difficult to figure out, right? A himself can finish the work in 10 days. Okay, look at the lower of the two values. 12 days, 10 days, I'll focus on 10 days. So A himself can finish the work in 10 days. Now A is getting some help. A is getting some help from B. So obviously if he's getting help from someone, then the total number of days obviously is going to be less than 10. He'll finish the work faster, right? Because there's someone else to help him. So obviously 10 to 12 is not possible. More than 12 is not possible. Obviously my answer has to be less than 10 days. This, so we can mark without even solving. So first, to understand the core concept, obviously it is going to be less than 10. So you look at, if you have 5 people, you look at the person who takes the least number of days. And then if they work together, then the total number of days is going to be lower than the least. What we say? Lower than the least. Okay, so let's say there was C, and C can finish it in 5 days. Now, if all 3 of them start working together, then the total number of days taken will be less than 5. It will be less than 5, lower than the least. Okay, that part is simple. Okay, now let's solve this question. So if I look at this question, A can do the work in 10 days. So in one day, A will do 1 by 10 of the work. Similarly, B can do in one day 1 by 12 of the work. So 1 by 10 work and 1 by 12 together. If they are working together, then they are going to do in one day, they will do 1 by 10 plus 1 by 12. Okay, 10 and 12 will have to take the LCM. The LCM is 60. So this is 6 and this is 5. So in one day, they are going to finish 11 by 60 of the work. Okay, so in one day, they are going to finish 11 by 60 of the work. Okay, so total work they'll finish in how much time? Okay, so total work they're going to finish in how much time? For this, though it is very intuitive, but I'll give you a formula for this. And in fact, this is the only formula that I will give you in time and work, nothing else. And this formula also, after some time, you will not need it, but just to make things clear, we'll use only one formula, is days required. And this days required can be hours required, minutes required, whatever. Days required is total work, okay, upon work done per day. Okay, days required upon total work done per day. Days required is equal to total work upon work done per day. Remember this. And after some time, you will not even require this. This is very, very intuitive. So here, I told you in the last slide that when work we are taking as unit, so total work is 1, right? It is 1 unit. So if I apply this formula, total work is 1 unit. Work done in a day is 11 by 60. Hence, days required will be 60 by 11. Okay, it is 60 by 11 or 5 by 11 days. So this is my answer for this question. And if you see, this answer is nothing but just reverse of this answer. So actually you don't need a formula, you just reverse this. In 1 day 11 by 60 happens, so total work you will need 60 by 11 days. That's all. Okay, though there are times when you might get confused, so just refer to this formula. Fine. So the answer for this question is 5 by 11. I told you it will be less than 10, that's for sure, because A is getting help from B. Okay, let's also try and do this question from percentage. Okay, I told you percentage will also give us the answer. So A, you can see that in 1 day he does 1 by 10, which means he does 10%. Okay. B does 1 by 12. Now 1 by 12 is slightly complicated, but if you know, it is 8.33%. Okay, so good thing with percentages that you don't have to deal with reciprocals. So work done in 1 day is 10% plus 8.33%, which is equal to 18.33%. So in 1 day, they are doing 18.33%. Total work, you remember, is 100%. So if I use this formula, total work, because I'm taking in percentage, I'll have to take 100% upon 18.33%. So here it will become complicated. This part was easy here, right? So somewhere you will have to do some calculation. Okay, so let's see this. So this is 100 percentage I can remove. 18.33 I can take as 18 1 by 3. Now 18 into 3 is how much? 54, 55 by 3. So this is 100 upon 55 by 3. This 3 will go here. So it will become 300 upon 55, or this I can simplify. This can be 11, this can be 20. So it is 20 into 3, 60 by 11. Okay, same thing that we had got here. Okay, so percentage is also fine, reciprocal is also fine, though most of the questions will do with reciprocal, because percentage, always the problem is that some values give you round percentage values, but in case percentage is not a very convenient value, then you will struggle later. Okay, so reciprocal is most useful at most of the cases. Fine. So 2-3 things. One, A can finish the work in 10 days, B can finish in 12 days. That if they work together, it is going to be less than the least, lower than the least. So it is going to be less than 10. That's one. And if you have answers which says, let's say 5 by 11 days, 10 days, 12 days, 15 days, you know that answer is 5 by 11. Okay, that's one. Second, this can be done by taking the reciprocals, work done per day, we add them, we get total work done in a day is 11 by 60. Okay, and hence the total time required is 5 by 11 days to do 1 unit of work. Sometimes the question may also say now that they're working together, they have to do double the work. They have to do double. So this many days they need for same work. If the work changes, their day will change accordingly. So if they have to do double the work, then time required will be into 2. If they have to do half the work, then time required will be this many days into half. So that adjustment you can always do. For example, let's say I define the work and I say the work is building a 100-meter wall. Okay, they have to build a 100-meter wall. This is the work. Okay, for which I know that they need 5 by 11 days. Okay, now they are working together, and now the work is that they have to make a 300-meter wall. Okay, so while work is not defined, but I can clearly see that my work has become 3 times. To do the same work, they need so many days. So to do 3 times work, they will need this. Okay, so now here when you're multiplying, better to deal with your improper fraction. 60 by 11 into 3 is 180 by 11. Okay, and then 180 by 11, you can convert it to a mixed fraction. So if I change my quantity of work, I say my work is double, triple, half, then your number of days will also get multiplied by the same factor, right? And then you will get your answer accordingly. So that is not a worry. Work can change. Work can change. Accordingly, my days will also change. Fine. So this is the core concept, and this will be using in each and every question. Of course, we'll be introducing some more concepts as well, but this I hope you have understood fully. Okay. Great. Let's move on to the next. There's one more interesting method. I told you we can use reciprocal or we can use percentage. We can also use an LCM method. Okay, this also is a nice method, though it not applicable everywhere, but wherever it can be applied, it works nicely. Okay, so what happens here is we check the number of days, okay, required for each person, and then we take LCM of the number of days as the, for example, in the previous question, if you remember, A was doing the work in 10 days, right? B was doing the work in 12 days. You remember this? Okay, so we'll write it like this. Let's write it like this. A 10 days, B 12 days. Together they start working, okay, and now you take LCM of 10 and 12, which is 60. Okay, so now this 60 is my total work. Okay, so this is a slightly different concept. So 10 days they take, 12 days they take. So together LCM I'm taking as the total work. So I'm saying 10 and 12, the LCM is 60. So total work is 60 parts. Okay, 60 parts, 60 pieces, whatever you call, but total work is 60 units, let's say. Total work is 60 units. Okay, and 10, so 60 divided by 10. 60 divided by 10 is 6 units. They do per, A does per day. A does 6 units per day. So obviously total work is 60 units. He does 6 units per day. 10 into 6, 60 units. Okay, so he will need 10 days. Similarly, B, 60 divided by 12, B does 5 units per day. B does 5 units per day. Okay, so this is per day, what you are writing here. Okay, together they do 6 units plus 5 units, they do 11 units per day. Okay, they do 11 units per day. Total work was 60 units. So number of days required will be 60 upon 11, which is 5 by 11. Okay, so this is also an approach that we use. Okay, so what we have done, check the number of days for each person of the group and assume total work to be LCM of the number of days. That is what we have done here. Okay, so if you see, we have taken 60, which is the LCM. So this is your first step. Then find working rate for each person, that is work done per day. So A, work done per day is 6 units, and for B, work done per day is 5 units. This is the second step. And third, divide the assumed total work. Assumed total work is 60, right? So 60 by the above, which is 5 plus 6. So 60 we have divided by 11 to get the number of days required, which is 5 by 11. Okay, for each person also you can find out 60 divided by 6. So A will take 10 days, which anyway is mentioned here. 60 divided by 5 is 12, which B will take. Okay, so individually they will take 10 and 12 days. Together they are doing 11 units per day. So together they will take 60 divided by 11, they will take 5 by 11 units. So this is the LCM method, which also works, and you can solve questions using this also. Let's take a slightly bigger example through this. So we have now C also. Okay, so let's solve this using the LCM method first, and then we will solve it using a regular method also. So A, B, C, they all work together. Okay, A can do the piece of work in 10 days. B can do in 12 days. And C can do in 15 days. Okay, LCM of 12, 10, 12 and 50 is 60. So we will say that my work is 60 units. Okay, A does the work in 10 days, 60 units. So 60 divided by 10, that means he does 6 units per day. Right? B does 12 days, 60 units. That means 60 divided by 12 is 5 units per day. Okay, and C does 15 units, 15 days, 60 units. That 60 divided by 15 is 4 units per day. Right? Now, if A and B and C work together, then they will do 6 plus 5 is 11, 11 plus 4, 15 units in a day. Right? 15 units a day. Total work is 60 units. So 60 by 15, they'll finish the work in 4 days. So A, B, C together can finish the work in 4 days. Very simple. This is the LCM method. Here we can make various combinations also. Let's say A and B are working, not A, B, C, but A and B are working. Then A and B will do 11 units in a day. So they will finish the work in 60 by 11 or 5 by 11, which is same as the previous question answer. Okay. Let's say B and C do the work. Then B and C, you can see they do 9 units in a day. Okay, 9 units in a day. So they will finish in 60 by 9, which is 6 by 9 or 6 2 by 3. Okay, let's say A and C do. So A and C, you can see that they do 6 plus 4, 10 units in a day. So they are going to need 60 by 10 or 6 days. So for any combination, we can find out. Very, very simple method. Okay, let's also do this from a regular reciprocal method. So A in 1 day will do 1 by 10. B in 1 day will do 1 by 12. C in 1 day will do 1 by 15. So A plus B plus C will do 1 by 10 plus 1 by 12 plus 1 by 15, which is equal to 10, 12, 15. The LCM is 60. So you have 6 plus 5 plus 4, which is 15 by 60. Okay, so 15 by 60. So days required is equal to total work 1 upon work done per day, which is 15 by 60. Hence 16 by 15 or 4 days. So this is the reciprocal method. So you can see both the methods, you can compare them and use whichever. Both are absolutely fine. Okay, so that is how this question would get solved. Okay, I hope we are clear till here. So this is the core of time and work. If you have mastered this, if you have understood this, okay, then you will not have any problem whatsoever. In the same question, we also later we will look at wages. Who has done how much work and how much should they get paid? That's a concept that we'll revisit in some time. Okay. Meanwhile, let's just focus on understanding this and doing some more questions so that we get complete hang of this. Okay. Fine. Let's look at one more question. Now this one says, Dhruv can complete a piece of work in 10 days, while Samir can complete the same piece of work in 15 days. They work together for 4 days, after which Dhruv gets, and you'll get a lot of situations like this, where someone left, someone joined later and all. Okay, so that should not trouble us. So Dhruv, everything you will have to do on a per day basis. So if you look at Dhruv, in 1 day, he does 1 by 10. Samir in 1 day, he does 1 by 15. Okay, together in 1 day, they do 1 by 10 plus 1 by 15. 10 and 15, the LCM is 30. You will get 3 plus 2, which is 5 by 30. That means they do 1 by 6. Right? So in one day, they do 1 by 6. Now 1 by 6, together they have worked for 4 days. So this is 1 day's work. They will do this for 4 days. Okay, so they do this, and after which, so you can see that what has happened here, Dhruv has quit. That means Samir is working, and Samir does in 1 day, Samir does 1 by 15. And he works for, let's say, some D number of days. I don't know how many days he'll work. He works for some D number of days to finish the work. That means equal to 1. Total work will take as 1 because we are taking as reciprocals, right? So this will be my equation. Dhruv works for D extra days. 4 days they both have worked together. After that, Dhruv has quit. So Samir works for D days. Okay, D days, X days, Y days, whatever you take. Okay, and Samir, you know, in 1 day he does 1 by 15. So in D days, he will do 1 by 15 into D, that is equal to 1. A simple equation. Okay, first part is 4 by 6. 4 by 6 is 2 by 3. 2 by 3 I will take on the other side. So you'll get D by 15 is equal to 1 minus 2 by 3 or 1 by 3. Okay, so D by 15 is equal to 1 by 3. This is 5. So D is equal to 5. Samir will take 5 more days to finish the work. As simple as that. Okay, so there are 2-3 questions that can be asked. First question, of course, is Samir will need how many extra days to finish the remaining work? Answer is 5 days for this question. The second question also can be, work will get finished in a total of how many days? And if the question is total of how many days, 4 days, remember, they both worked, and then Samir worked for 5 more days. So actually total time taken is 9 days. This also can be a question. So total number of days taken to finish the work is 9 days. Okay, so 9 days will be the answer in case the question is total how many days are required to finish the work. Okay, so I hope you are clear. Very simple question, but you will have to make equation, and this is the equation that you will be making. But when you get per day work, then it's very simple. This is per day work. Okay. Second, there can be one more approach to this. Okay, where I do not find D plus S. I solve separately for them. Okay, let's look at that also. That's again an interesting concept. What I can do is, let me say, let's remove this part and let me use another color. So Dhruv has worked for 4 days. Okay, and Samir has worked throughout. Samir was working with Dhruv also, and later on also Samir continues working. So let's focus on them individually. Dhruv does in 1 day, he does 1 by 10. He has worked for 4 days. So he would do 4 by 10 work. And Dhruv, so Dhruv is 4 by 10, and Samir has worked for 4 days plus D more days. Totally he has worked for so many days, and he has done 1 by 15 every day. Okay, so this is the work done by Dhruv. This is the work done by Samir, and together they have finished the work. This also can be my equation, where I'm looking at Dhruv separately and Samir separately. I say, okay, if I look at total number of days, Dhruv has worked for only 4 days, and Samir has worked for 4 plus some more days, which is D. So total. So I'm looking at them separately. Okay, so I'm telling you all because you should know how to make these equations, and there are various ways of making these equations, because some questions you might be required to make this equation. Okay, so let's solve this. So this is 4 by 10 plus 4 by 15 plus D by 15 is equal to 1. Okay, so D by 15 is equal to 1 minus 4 by 10 minus 4 by 15. 10 and 15, the LCM is 30. So let's take 30. So I get 30 minus 12 minus 8, or 30 minus 20, or 10 by 30, or 1 by 3. So D by 15 is equal to 1 by 3, or D is equal to 5. Okay, so Dhruv has worked for 4 days. Samir has worked for 4 plus D, and D is 5. That means 9 days. So Dhruv has worked for 4 days and Samir has worked for 4 plus 5, 9 days, which is what we got from the previous solution as well. So solution wise it is same, but I'm just giving you one more approach to solve this question. Okay, fine. Let's move on to the next question. Okay. A and B can complete a work in 12 days. B and C can complete the same work in 15 days. A and C can complete the same work in 20 days. If they work together, in how many days can they finish the work? Now, if you see, I don't know the individual work of anyone. I only know combined work. Okay, no problem. Let's say in one day, A and B will do how much work in one day? Okay, see, always this you will have to focus on one day, right? So in one day, A and B together will do 1 by 12. B and C together will do 1 by 15. And A and C together will do 1 by 20. So now if you add, let's say all these groups are working together, obviously it can't happen because A is working twice, B is working twice, but hypothetically, if all these are working together, then on the left hand side, you will see 2 times A plus B plus C, okay, is equal to 1 by 12 plus 1 by 15 plus 1 by 20. Okay, 12, 15, 20, the LCM is going to be 60. So it is 5 plus 4 plus 3. 5 plus 4 is 9. 9 plus 3 is 12. 12 by 60, which is going to be 1 by 5. Okay, but one important thing to note here on the left hand side, it is twice of A plus B plus C. Okay, so A plus B plus C is going to be 1 by 10. Okay, because this 2 obviously will go on the right hand side and it will get divided. So what this means is twice the work done by A plus B plus C together is equal to 1 by 5. Okay, that means ABC in one day, they do 1/10 of the work. Okay, this 2 will come, right? Because when you add this, you can see that A will come twice, B will come twice, C also will come twice. Fine. Okay, now what do we do? This question is already answered. The answer is 10 days. Okay, not 5 days. 5, you are getting this 1 by 5, but this 1 by 5 is wrong because you have 2. So answer is going to be 10 days. Also, what else can I answer here? Can I answer the individual time taken by each one of them? Yes. So for example, if you look at A plus B. A plus B, I know they take 1 by 12 days. Let's subtract both. If I subtract both, A and B will get cancelled. Work done by C in a day is 1 by 10 minus 1 by 12. Okay, 10, 12, the LCM is 60. So you get 6 minus 5, 1 by 60. In one day, C does 1 by 60. That means C can finish the work in 60 days. So C is 60 days. Okay, similarly, if I modify this and I take, instead of A plus B, I let's say take A plus I take the value as, let me change this to A plus C. A plus C is 1 by 20. So then if I subtract, I'll get B is equal to 1 by 10 minus 1 by 20, which will LCM will be 20. You will get 2 minus 1. So 1 by 20. That means B can finish the work in 20 days. Okay. And similarly, if I subtract B plus C, Okay, let me just overwrite here only. B plus C is 1 by 15. When I subtract them, then I get A is equal to 1 by 10 minus 1 by 15. The LCM is 30. 3 minus 2, which is 1 by 30. That means A can finish in 30 days. So I can get individual values as well from this. Okay. Can we also solve this using the LCM method? Let's see. If I try that way, then A plus B, 12 days, B plus C, 15 days, A plus C, 20 days, together LCM of 12, 15 and 20, 60 days. So 60 units, right? So work is 60 units, and 60 divided by 12, work done is 5 units per day. Here it is 4 units per day, and here it is 3 units per day. 3 units per day. So together they do 5 plus 4 plus 3, which is 12 units in a day. Right? But again, this 12 units is by 2 times A plus B plus C. Okay, so 2 times A plus B plus C do 12 units in a day. That means A plus B plus C do 6 units in a day. There's no reciprocal here. So 6 units in a day. Total work to be done is 60 units. So they are going to need 10 days. Okay, so same thing. So A plus B plus C will work in 10 days. You'll get the same answer by taking the LCM method also. So LCM method, as I told you, obviously can be taken in these questions. But one that always works is your reciprocal. Okay, because LCM, you may not get a round figure sometimes, and that can complicate the question at times. Fine. Okay, let's move on. Okay, let's look at one more variation. So M can complete a piece of work in 60 days. N can do the same work in 50 days. They started together. After how many days should N leave? This is very similar to what we had done earlier, right? So that the work is finished in 36 days. N leaves. Okay, that means M continues throughout. So let's use the approach that we had done earlier, where we look at both of them separately. So M does 1 by 16 a day, and M works till the end. Total work has taken 36 days, so M has worked for all 36 days. So M will do so much work. Okay. N, after how many days should N leave? So let's say N has worked for N days. Every day he will do 1 by 50. That should be equal to 1. Okay. M has worked for 36 days, so M will do so much work. N has worked for N days, so he'll do so much work. Total, they should complete the work, right? Okay, 36 by 60 is 6 by 10. 6 by 10 plus N by 50 is equal to 1, or N by 50 is equal to 1 minus 6 by 10, or 4 by 10. 4 by 10 is nothing but 2 by 5. This is 10. So N is equal to 20. N should work for 20 days. Okay, that is the answer. Here I have looked at both of them working separately. I've counted them separately. Let's use the other approach where I say that they work together. Though that is not required. Why would you want to add a step? But let's do that also. So if they work together, and they are working together, but we have solved that separately. In one day, they will do 1 by 60 plus 1 by 50. 60, 50, the LCM is 300. Okay, 5 plus 6. So 11 by 300 work they will do. Okay, so let's say they work for N days. N days they work together. So N into 11 by 300 is what they will do. Okay, after that, M continues to work. N has left. M continues to work. Okay, total work is taking 36 days. So the days that remain is 36 minus N. Okay, and for that M is working, M will do 1 by 60 every day is equal to 1. So this is the second equation, but you can see it is a more complicated equation than what we made here. Okay, but you must know the approach, whether you use it or not. Okay, so let's look at this. 11n by 300 plus 36 by 60 or 6 by 10 minus n by 60 is equal to 1. So let's move this on the right hand side and let's combine them. 300 and 60, the LCM is 300. So 11n minus 5n is equal to 1 minus 3 by 5, or 11 minus 5 is 6n by 300 is equal to 2 by 5. Okay, so this will give you 3, this will give you 100, this will give you 20. So n is equal to 20. Okay, so absolutely same answer, but two different approaches that we have used. Okay, so I hope we are clear till here. Great. So let's look at one more question. Anil can do a job in 20 days, Sunil can do it in 40 days. Again, so people joining, leaving and all that. Okay, so Anil in one day, he does 1 by 10. Sunil in one day, Anil can do in 20 days. So 1 by 20 and Sunil is 1 by 40. Anil starts the job. After 3 days, Sunil joins him. Again, after a few more days, Bimal joins. Okay, Bimal also joins. Okay, so first Anil works for 3 days. Let's look at that. So 1 by 20 is Anil's work every day into 3 days. Okay, after 3 days, Sunil joins them. So both of them work for few days. After a few more days, Bimal joins them and they together finish the job. If Bimal has done 10% of the job, okay, then in how many days the job was done? Okay, so how do we approach this? There are 3 parts. First part, only Anil working. Second part, Anil plus Sunil working. And third part, Anil plus Sunil plus Bimal working. Okay, so I can look at this. One is I divide this into 3 parts. Second approach, which we were using earlier, I say that Anil has worked for the whole part. Anil has worked throughout. Okay, then Sunil has worked this much, and then Bimal has worked this much. I look at their contribution separately. I can do this also. Okay, so which approach do we use? Let's use the second one. Okay, then in how many days was the job done? Okay, now if you look at Bimal, there's one very useful hint. Bimal has done 10% of the work. That means Bimal has done 1 by 10. So Bimal actually can be removed. Bimal is not important in this approach. Bimal has done 1 by 10. That means Anil and Sunil have done 9 by 10 of the work, right? 90% of the work is 9 by 10. Okay, let's say total number of days, and you also know that Sunil joined after 3 days. Okay, so let's say the total work has taken X days. Okay, so Anil has worked for all the X days. So he does 1 by 20 per day. X days, he will do X by 20. And Sunil joined 3 days later. So he worked for X minus 3 days. He has worked for 3 days less. And he has done 1 by 40 per day. So this is the work done by Anil and Sunil, which should be equal to 90%, 9 by 10. Not full, because Bimal has also done 10%. Is this equation clear? Total number of days to complete the work is X. Anil has worked for all X days. One day he does 1 by 20, so X days he will do X by 20. Sunil does 1 by 40 in a day. He has worked for X minus 3 because he joined 3 days later. Bimal, we have taken him out of the equation because Bimal had done 10% of the work that we already accounted for. So I'm saying Anil and Sunil will only do 90% of the job. Okay, let's solve this. x by 20 plus x by 40 minus 3 by 40 is equal to 9 by 10. Okay, let's combine both sides. So this is 40. So you have 2x plus x is equal to 40 here also. So you have 9 by 10 will become 36 plus 3. Okay, 40 gets cancelled. You have 3x is equal to 39 or x is equal to 13. Total number of days required are 13. This should give us the answer. Because there's no point in going after when did Bimal join, because we do not know Bimal's what is the rate at which Bimal works. Even that data is not there. So best to say that Bimal has 10% done 10% of the job. It does not matter when he came and how much he works. I know that he has done 10%. So I'll focus on Anil and Sunil. They have done 90%, and hence I can make a very simple equation and I can solve. Okay, so that is how basically, so this equation is the key here. And all these questions, remember, can be solved in 2-3 ways. I'm looking at which is the easiest way, which is the best way. Best way is this. Okay, so we have not used this approach. We have used this approach. Okay, Anil has worked for all x days. Sunil has worked for x minus 3 days. And Bimal, how many days I don't bother because I know how much work he has done. Okay, so this is how this question gets done. Hope you all are clear till here. Fine. Okay, so I think we have covered some very important concepts here as the first class. Now we'll pause here. Okay, and I will want you to revisit all the questions once again, solve what we have discussed, solve some similar questions from your practice material, and then in the next class we will move on to doing some more questions of the same variety, some tougher questions, and then we'll move to the concept of man days and man hours. Okay, thank you so much. Take care and see you in the next class.